Maciej Fiałkowski, and I would talk a bit about creating a PHP interpreter using PyPy technology. A few words about me. I'm a PyPy core developer, and I've been working on various aspects of PyPy, from raising funding to just-in-time compilers and garbage collector, a bit everything. If you have a question, just, I don't know, raise your hand or something. Feel free to interrupt me. Let's make it slightly more interactive than usual. So PHP, before you run away screaming, PHP is absolutely horrible. I agree, and anybody who tried to using it will agree. However, it's by far the most popular language on the web, which says something more about the web than PHP, if you ask me. But well, this is the reality we happen to live in. I don't like JavaScript either. PyPy is proven, quote, quote, technology for speeding up Python, as in it might or might not speed up your program. However, the technology is generally quite sound. We do have quite good results from applying our technology to Python interpreter, which is quite sophisticated. And another question is like, OK, fine. So who has PHP performance problems? Well, definitely Facebook. Facebook is developing their own solution. But also Wikipedia, WordPress, people who run various kinds of hosting. So there is generally demand. So the idea is to build a PHP interpreter, which will be more or less commercial technology, and sell it or license it to people running various websites. The current plan is to make the core of PHP running open source, and then sell a pro version which will have more extensions and stuff like this than the open source version. And I would like to say that making a very fast open source PHP is probably not doing world any good. So I feel happy with that. What's the current landscape? We have Zend. Zend is a simple bytecode-based interpreter. Larry would disagree with me here, but it's very much like CPython in a sense. Like, he disagrees very much. It is, however, a simple bytecode-based interpreter. It has a bytecode dispatch loop, and then the bytecode dispatch loop various functions call other functions that are implemented in C. And the end is a giant standard library that implement all kinds of strange tools that PHP has, like 700 different ways of sorting an array and all kinds of this stuff. Then there is a hip hop, which is a Facebook attempt to compile PHP to C++. Allegedly, it worked for Facebook and pretty much didn't work for anybody else. It ended up building for Facebook. I don't remember, what was that, 10 gig or 2 gig binary?
10 gig.
10 gig binary. Original. OK. So if you build a 10 gig binary, first of all, how do you deploy that? So allegedly, they used BitTorrent. Well, it's a problem, right? How do you copy a 10 gig binary to like 100,000 computers, something around this number? Second of all, your cache misses will be quite common. You might even miss your RAM sometimes. Like, there are issues. So why? This is a good question. It turns out that PHP, despite the fact that it's kind of static and kind of nicer to optimize than Python, it doesn't have sys.getFrame, it doesn't have sys.xinfo, it doesn't have various things like built-in debuggers. It's still dynamic enough that the worst case scenario, which is more and more obscure, is actually bad. And this is bad for creating compilers. So if you build a static compiler, say you write a GCC or a tiny C compiler, you end up saying, OK, fine. So this is the function. I have to assume the worst that I can potentially prove. In Python, this is next to impossible, because you quickly say, I don't actually know what this function does. I have to assume it can do anything. So it turns out in PHP, you cannot prove all that much. You can sometimes prove a lot of things, but it's still not enough to build a complete static compiler that's actually nice and working fast. I mean, it's still faster than Zend, but it's not ideal. Now, hip hop team is working on HHVM, which is a successor to hip hop. It's based on JIT. So it compiles stuff dynamically to assembler as it goes, very much like originally the main JIT that people use were Hotspot, .NET, but also Lua JIT, modern JavaScript engines, PyPy. Those are all JIT compilers. It's progressing. Like right now, it's tied to x86 64-bit assembler. It's not massively faster than hip hop and has all kinds of issues, but it's progressing. So I think my claim is that we can do better than that. What's the current benchmark landscape? And the answer is benchmarks are hard. Who knew? I've seen mostly either numeric benchmarks for PHP or language shootout. And language shootout is really bad. They're not very representative for... So they're not very representative, but it's very hard to make a representative set of benchmarks in multiple languages in general. So if you say a computer language shootout is something that say, we have a set of programs in C, and now let's implement in other languages. But it turns out that you don't typically write programs that you would write in C in, say, Python. In Python, you would write something like a web server. If you write a web server in C, you're either insane or you write in Apache. Like, it's very hard. Like, it's or Google or someone like that. There are no pet projects that serve HTTP in C or C++. People typically don't do that. So it's very hard to have a representative set of benchmarks. Hip hop, last time I checked, was like 2 to 4 times faster than that. HHVM is slightly faster than hip hop. But there is no real world PHP benchmark suite. Part of the goal of the project is to create one. So to have something like speed PyPy.org that runs, say, Wikipedia or WordPress or stuff like large PHP projects, or I don't know, even some numerics. But the idea is to mix it with various things. So hard to say. Like, I don't know. That's the answer. I think our technology is good, but I don't know. So a few words about PyPy. PyPy is, first of all, it's a fast interpreter for a Python language. But also, part of PyPy is a toolchain for constructing interpreters. So who knew that? OK, quite a few people. It's our problem to name it PyPy 2, just to avoid confusion. So it should be really called RPython, where R stands for restricted. The fun fact is that it comes with a just-in-time compiler, but this is not your average just-in-time compiler. So our just-in-time compiler, I'll show it later, does not understand Python at all, which is surprising, but I'll show it later. So what about our Python? It's an implementation language, and that can be compiled statically to C. In a sense, it's very similar to Python, except our goals are slightly different. So we do not aim to compile the full Python. We aim at compiling enough Python so we can use it. But the trick is that we can generate a just-in-time compiler for the same interpreter. So say I have a code here. This is carefully chosen tuple comparison implemented in PyPy. It does simple stuff. So tuple is implemented as two things. Well, tuple is implemented essentially as a fixed size list. You would ask, why not a tuple? Why a list? Well, because in C it will be array of static size. OK, fine. So we compare the length here. And if the length is not equal, then we know that the tuple is not equal. And we return space.w false. What's a space.w false? It's simply an up-level false. So it's a Python object that represents false. It's an instance of a bool object or wbool object or something like this. And then it's simple Python. So here we iterate over items. And then here the idea is to not compare pointers to those items, but to call space equality. Because in Python, you can overload under equality. You can do all kinds of crazy stuff. So this space.eqw is actually a very complicated mess that checks if the right-hand side is a subclass of the left-hand side and then calls the stuff on the right-hand at first. You don't want to know. The point is, this is like a function. We do not implement this function twice. Because typically what you would do, say in JavaScript engine, say V8, would have an implementation once here for the interpreter, and the second time for the JIT, which will compile stuff to assembler. That's a lot of work. So we try to avoid doing that. And instead, we have one way that translates it to C, and the other way that translates it to something that emits assembler. If I have time, I'll show you on a simple example how this works, like from a high level. So the point is we have just-in-time compiler each time we have an interpreter. So our Python is great for writing interpreters. Hooray. It's also a horrible language. Like, I would not advise to anyone not writing interpreters to use our Python, just to stay clear. I suggest reading a blog post by Laurie if you actually want to implement an interpreter. Laurie implemented his Converge VM, I believe, in C, and then decided, oh my god, this is getting too complicated, and implemented again in our Python and got much better results in much shorter time. Laurie works for King's College London, I believe. And he's a lovely Englishman and writes really well. So let's introduce Hippie. Like, the idea is that we wrote PHP interpreter in our Python. We are not quite done yet, but we are working. We are trying to be back-to-back compatible with Zend. I mean, this is the only way you can run any programs. Like, PyPy is back-to-back compatible with CPython. So if we have, on one hand, a Python language description, on the other hand, a CPython implementation, and they disagree, we'll usually do what CPython does, not what the language description says. And the corners where it matters are very obscure. So the idea is that we write interpreter, and we get just-in-time compiler for free, quote, quote, where for free means that we spent the last 10 years building infrastructure, but we get it now for free. Fun. The preliminary study was sponsored by Facebook. It was a 2-month-long project where I was working on implementing a small subset of PHP 1.0 to see if this approach is viable. So I think we disagreed what the report said, in that I said that the approach is viable, and they said it's not. However, the study showed that for this particular subset, well, that was not the disagreement. The study showed that for this particular subset and this particular implementation, it was faster than hip hop by quite a bit in 2 months, plus the 10 years that we spent on PyPy. However, what we disagreed upon is how much more work it is to implement more of PHP and how this will affect performance. So the question is, like, we are now trying to prove them wrong, essentially. But the performance reasons were quite good. PHP is hard. Like, I can show you some of the standard library. Hippie. Let's say, so this is various kinds of array functions. So we have intersect. This is like implementation. It's very similar to PyPy source, except you have like all kinds of warnings that you call it with wrong types. So you intersect the array. This is another kind of intersection that's almost identical, but not quite. This is another type of intersection, which is almost a copy of that, but if you try to share code, you figure out that all the details are different. This is another one. And this is normal array intersect. So PHP is quite crazy. You also can, like, who programmed in PHP at all? Quite a few people. I'm sorry for you. If you do that, say you define a function that does echo this, right? OK, fine. I define the function. I can call it with 13. It will print 13. OK, but now we can do like this. dot. Dot is a string concatenation, and I can call this. So there's a namespace that you can randomly access. However, you cannot overload that namespace, as in, if you try to define the function again, it complains, it's a fatal error, and blah, blah, blah. So this is like one example. There are more. There are tons of. You can call functions by name that way. There's an equivalent of star args in Python, except completely obscure. If you pass extra arguments, they're silently ignored and put somewhere in limbo, but you can like fish them from there. There's a locals equivalent. Locals in Python will return you a dictionary that's a copy of locals. So you have that. It's what is it called? Implode. Larry, do you remember?
I can't remember.
And there's a one called explode, which does the opposite, which is takes a dictionary and puts everything in the local scope. So they're crazy semantics, but also fun thing is you get, like if you say array 1, 2, 3, then this will make a copy of an array. So if you say now I want to do like this, they're different. $B is a copy of $A. So a simple assignment or a simple passing to a function as an argument will typically pass stuff by value, which makes giant copies. So what they do is there's ref counting. If the reference count is 1, then you do copy on write, which essentially means you don't copy if you don't need to. And stuff like this. So it's on one hand it's hard, but also it's fun to like implement this strange set of requirements. But my point is that, and essentially my whole point is that once you implement all the mess, getting fast is much easier than for getting fast as something where you have to implement the interpreter on one hand and a JIT on the other hand. So because we do get JIT for free, and PyPy is actually quite good technology. We have various interpreters already implemented in PyPy, like Prolog, for example. What was else there? Scheme? There are various things that you already use PyPy technology to. Ruby, yes, Topaz, project by Alex Gaynor, where it actually shows quite decent performance. How the basic idea works? The basic idea works quite the same, as in you have the interpreter and stuff. So run main, what we'll do, so this is like dispatching based on bytecode. Who has ever written an interpreter? Oh, quite a few people. The essential idea is you like read the bytes from the bytecode and you dispatch based on this. And this is magic. Anyway, at the end of the day, it will call the correct method on the interpreter. So load const, for example, would read the const from the bytecode and then push them on the frame. It's very similar in PyPy, actually. If you look at PyPy opcode, so load const. Here you like get the constant and push value. It's the very similar idea, and they're actually based on the same design. So it's a very simple bytecode interpreter, and then it comes with a giant standard library that does various stuff. It's all quite typical as far as writing interpreters is concerned. There are a few interesting questions, like how do you integrate in a sense that you start in a normal setting where PHP works as a CGI. You start the interpreter, you process everything, you load everything, and then you drop all the data. So we need some sort of persistence that would not be visible to user, but will be able to like store the JIT data and stuff like this. The point is that the landscape is quite different, but there are various optimizations that do not make sense in Python that you can do in PHP that make tons of sense. because it's done that way. I can show you, like, if you look at a very, very simple interpreter. Test example, I think. So this is an interpreter that has 3 bytecodes in total. One increases the accumulator, one jumps back 3 positions, and one decreases the accumulator. And this is the code that I'm executing. So it's like increase, 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 jump back, and then increase, decrease. Not a very, very sophisticated program, but what we'll do, there's also an extra exit condition that jump back will exit if the accumulator is higher than 100. So I have like here add and sub defined, and here is the main interpreter loop, which really looks like this. So this is normal Python. You can just go ahead and run it. However, the trick is that you have here it says this is the JIT merge point, which means this is the main interpreter loop, and this says can enter JIT, which means I just closed the loop in the interpreter. So if you run it, test example. So this is the flow graph of the interpreter. So if you zoom in, you see that like it calls the JIT merge point, then gets item from the bytecode, compares it, and then does a Boolean value on the comparison. And those are various implementations of the opcodes, and then more comparisons. And those are the small functions sub and add that do exactly what they say they do. If you look carefully, you can see that here, for example, here, it knows it's an integer. So we are really not running full Python. We are running a subset of Python that can be statically typed carefully. OK, this is the same thing except lower level. And hop, this is the thing after we traced. So the JIT got generated, and then it traced. And all it does is like 3 additions. Debug merge point is just for debugging info. A comparison and a guard false, which means exit the trace if I3 is guard false, so if it's higher than 100. What it did remove all the bytecode dispatch and all the mess like this, and this gets compiled to like really efficient assemblers, like few registers and stuff like this. So this is a very simple interpreter. We start there and we end with PHP, and stuff happens in between. We are also hiring. So if you want to work on something really obscure but also challenging, talk to me. You'll work with me and Armin, among other people. We are a fully distributed team. Armin lives in Switzerland. I live here. Rafael lives in Poland. And there's one guy who I think lives in Bristol, but I'm not quite sure. He's on the internet, though. And I think this is pretty much it. Feel free to like mail me or ask me questions. Yes? Microphone. No? OK, I'll repeat your question.
Are you doing a PHP interpreter because someone on the internet was wrong?
Essentially. I also try to make money, but like essentially.
That thing you used to visualize the code, I want it. Where do I get it?
You get it on Bitbucket. It's in .viewer. Or actually, it's in PyPy. It's PyPy/.viewer and uses Pygame, which is really hard to get working on Mac.
I've managed it.
OK, if you're done with that, then yes.
Is it just for doing stuff like analyzing the JIT, or can it be used for arbitrary code?
It uses GraphVis for like putting stuff together, and then viewer is like pure graph viewer, so you can fit it with anything you want. I've seen it used. Somebody wrote a bachelor thesis on visualizing firewall rules or something like that. It can be used for really anything. Yes?
You obviously have been involved in writing PyPy, but how does our Python compare to, say, LLVM as an intermediate language?
So RPython is an implementation language. You actually type in RPython. In LLVM, you don't write stuff in LLVM. At least I hope you don't, because it would be really horrible. However, like, this is not the only difference. So RPython is a thing that you use. So say if you use LLVM, what typically you do is you write your stuff in C++ and then emit LLVM, right? So in PyPy model, you write RPython and you're done. You don't have to emit anything because it deals with whatever. But also, it does better high-level optimizations than LLVM and worse low-level optimizations. So LLVM is really good at stuff like register allocation and stuff like this. But for dynamic languages, it really, like, before you get there, is like last 20% of performance. They have like 20x to go there. So you need to, LLVM will never remove an allocation for you, for example, or it will do inlining, but not on the level that you want it to do. So a lot of stuff in PyPy, like all the optimizations that we do, is, for example, a special support for frames that are optimized. LLVM does not have this because, well, in LLVM you just use CPU frames that are optimized a bit by design. There is not much to do. But in Python, like, you really don't want to allocate the PyFrame object. You would rather have bits and pieces from there and know how to reconstruct it. So we do a lot more high-level optimizations. I think there are actually very good papers describing exactly PyPy approach, and it shows how it's different than LLVM. How do you find them? I think you just look for Karl Friedrich Bolt on Google Scholar, and you'll find like all the papers. Yes?
Can you clarify that last toy example, I think? Was that like a test or a real bytecode implementation, like the increase 3, jump back 3? Is that a real thing or just a test of how the interpreter is implemented?
What's the difference?
Is it a toy example or is that a real bytecode, set of bytecodes that you would encounter?
No, what's the difference? Like, the example is obviously toy, but also it's a real language. Like, whether
It's a real
would you?
implementation of a toy language, which is simple enough for the testing.
That's what I want to
Okay.
Thank you.
Would you like to write stuff in that language? No, but it's probably not even Turing complete, but almost. Okay.
What?
No more questions. Thank you.